We'll continue this sequence of introductory videos demonstrating intelligent objects by adding floor slabs, and we'll start with the ground floor slab. You may recall that we already had what looked like a ground floor slab in the earlier demonstration videos, but that was just a conventional MicroGDS object that I created to give us a base to work from. What we're going to now is create a proper intelligent object slab. Now I've deleted the conventional 3D object, but I did use it to create some construction lines for us. So we'll switch to the 2D plan view, and we'll hide all of the graphics that we're not interested in to make it easier for us to see what's going on. So we'll double click on the slab layer to make it the current editable layer. If we right click on the layer name, we can select invert selection from the pop-up menu and then click invisible to make all of those layers invisible. And you can see what we've got here is the outline in construction lines of the original slab extent, with a little extension here, a D-shape extension that's going to be the basis for a revolving door. I've also created a piece of substructure here. This is actually a lift pit. There are no intelligent object implementations for substructure in this release of 2010, but they will be coming along. So we start with a new object, floor slab, and we give it the first facet IFC slab, colon, click on OK, and we snap to place the hook point, and I'll just use a corner here, it's just for convenience. Okay, we can now go to our properties window, set the object style to concrete screed. Again, we've only got the one choice. That populates the fairly meagre list of properties that we have to set here with default information, which we can just accept actually because it's reasonable for what we're doing. It's saying that the underside of the slab here is 200 millimeters below the finish level, and it comprises 150 millimeters of slab and 50 millimeters of screed. Close the box to say that we've accepted that, and then we can use the area trace command. Any construction commands we could actually use the O-line command if you just wanted to draw around, or the trace command, but we use the area trace command. Just snap anywhere inside the construction lines, ignore the lift pit for the moment, and that's now created the slab. So if we go to our perspective view, we can see that that slab's been created. We just zoom in onto the D area, and you can see quite obviously you've got two layers. One is the screed and the other the slab itself. Go back. If we look in this corner here, this is where the lift pit is going to be. Switch back to our GA plan. The Z lock's on, so we're not going to snap to the bottom of the lift pit, and we just simply select the rectangle command without any dimensions set. If we press return, you can see that it's just set to using snaps, and snap onto the two opposite corners of the lift pit. And if we go back to our perspective view, you'll see that that's made a hole to suit the lift. Straightforward. So let's just restore that perspective view. We're not going to turn on the other layers yet because the next step is going to be to create a rather more complicated first floor slab. We'll go on to create the upper level slab now. So first of all, we're in object mode already, so we'll select the construction lines and delete them, and we'll open the window editor with F2, and let's make the ground lower level slab hittable. And if we go to our layer list, we should find that I've already created a layer, here we are, for the first floor slab. Well, that's the internal wall ones, it's down here, first floor slab. There we go. Make it editable, and let's just give it a different colour. Double click to make it the current layer. Close that. And we'll see that that's brought in some construction graphics that I've created to outline the upper level slab. If we orbit around, you'll see that those have been created at the actual floor level of the slab. So what we'll do is we'll move the axes up onto those graphics so that we're adjusting the working plane to suit the first floor level, and we'll lock the Z plane to make sure that everything we do is working on that floor level. And just one observation for you, the graphics here, these curved graphics which are the wide radius curve, As for the ground floor internal walls that we created in an earlier video, I've created these as an arc, but because they are very large radii and the faceting that MicroGDS applied would not be of fine enough resolution, I've used the alter facet command to add the facets to the line itself. If we look at this in a 2D view, so if I open the GA plan for that same view, if I select this arc for example and I apply a line style that I've designed to check vertices positions, you can see that highlights each of the individual facets. Each of those circles is superimposed over a vertex so that we can see. Let's have a quick look in 3D, and while it's selected you can still see the line style displays. And likewise this one here, if we do that as a check vertices, you'll see that that is also a faceted line. Okay, so if we select the whole thing and change it back to our dash style that we use for construction lines, we can do exactly the same process that we did for the ground floor slab. And so we do object new, floor slab, IFC slab, colon, click on OK, and I'm just going to snap onto this intersection here for the hook point. And we do the Control Q to bring up the properties window, set the object style to concrete screed, and we can leave all the values as default values. We're not really that bothered about changing the slab thickness or the screed thickness at this time. That kind of information is the stuff that develops as the project design proceeds and the structural engineer comes up with his more detailed calculations. And then we can use our area trace command again, the 0 offset, and snap somewhere inside the outline of the slab, not over the lower level slab, because that also has outline graphics that could easily be picked up instead. And the slab's created, so we can see that that's been created as a solid of 2 layers, one for the screed and one for the slab beneath it. And again you can see the faceting, which should give us a nice smooth curve if we do the renderings and what have you. We've got some holes to place in the slab, including the lift shaft and 2 apertures for the escape stairs. So let's switch to our GA plan view, and we can just set our rectangle command, and again without any values set for X or Y, just snap onto the 2 corners of the rectangle, and when we switch back into 3D view we can see that the hole, I should go to the perspective view, that's still showing the 2D slab. An easy mistake to make, bad habit to get into. So in the perspective view we can see that the hole has been correctly made. So we'll turn on, let's restore the view first of all, so let's restore perspective, and we'll turn on every other layer. So if we right click on the current layer, invert selection, we can make them all hittable, and close that, and we should now see all of these layers superimposed. So let's just wheel around till we can see one of the staircases, and just zoom in, and we can see just the very top riser there. So all we need to do is to construct a rectangle from, let's say, from the corner of the stair to the corner of the wall. Actually, let's just make it to the edge of the wall there, and then we can use a segment move command to pick the edge of the slab and just drag it across. If we pick the right line, that is. Okay, material concrete, screed. There we go. Okay, because there are multiple graphics with the 3D solid, and the actual reference line is the line that we actually wanted to find at that point. And we can take that reference line and copy it across, or we can simply, because it is just a rectangle, we can simply draw the rectangle on the other side. Again, from the, let's just wheel the view across from, let's say from there, from that point to that point. So we've got the aperture for the stair now.